Explore how to determine volume of this river or channel. From this video we could learn the method to measure the river discharge. River discharge, also known as stream flow, refers to the volume of water flowing through a river channel per unit of time. It is usually expressed in cubic meters per second, cubic meter per second. Discharge is a key component of the hydrological cycle because it represents the movement of water from the land surface back into oceans, lakes, or reservoirs.
River discharge, also known as stream flow, refers to the volume of water that flows through a river channel over a specific period of time. It is typically measured in cubic meters per second. We use the data for: first, water resource management; second, flood prediction and management; third, ecosystem health; fourth, sediment transport. Stream discharge can be measured using volumetric gauging, buckets. This method has limitations. Only useful for flows less than 20 liters per second. Whole flow must be channel led to the bucket. Flow estimation. Float gauging. Float gauging is one of the simplest methods to estimate stream flow or discharge in rivers or open channels. It uses a floating object such as oud, plastic ball, or an orange placed on the water surface to measure surface velocity, which is then converted to average velocity and multiplied by cross-sectional area of the flow. Advantages for this method is: very cheap and simple method, requires minimal equipment, good for rough estimates in small streams or during field surveys. Limitations for this method is: less accurate compared to current meters or modern flow sensors. Affected by wind, surface turbulence, obstacles, and float type. Not suitable for very wide, deep, or fast-flowing rivers. A weir is a small structure, like a dam, built across an open channel or river, with a notch or opening that water flows over. By measuring the head of water, the height of water above the crest of the weir, we can calculate the discharge flow rate using hydraulic equations. Advantages: 1. More accurate than float gauging. 2. Can measure small discharges effectively, especially V-notch. 3. Simple and low maintenance once installed. Limitations for this method. First, requires construction, installation in the channel. Next, it also can disturb natural flow and trap sediments. Third, accuracy depends on proper calibration and installation. Last, this method not suitable for very large rivers. A staff gauge is a simple measuring device, basically a graduated vertical scale, like a big ruler, fixed at the side of a river, reservoir, or channel. It is used to measure water level, stage, directly by visual reading. The advantages of staff gauges are: very cheap and simple to install, and it provides a long-term record of river stage. Also easy to read manually, or can be paired with automatic water level recorders. A staff gauge is a graduated scale used to measure river stage. With a calibrated stage-discharge relationship, it becomes a practical tool for estimating river flow over time. Dilution gauging estimates stream flow by injecting a tracer, commonly salt, sodium chloride, into a stream and measuring how much it gets diluted downstream. Advantages: this method are: works in turbulent, irregular, or inaccessible streams where velocity area methods fail. Good for mountain streams with rough beds. Salt tracer is cheap, safe, and easy to detect using conductivity meters. Both are practical when other flow measurement methods are difficult, especially in turbulent or inaccessible streams. A current meter is an instrument used to measure the velocity of flowing water at specific points in a river, stream, or channel. It typically has a rotating element, like cups or a propeller, that spins when water flows past it. The rotation speed is proportional to water velocity. Types of current meters that we could found. 1. Cup type, price meter, rotating cups, often used by hydrologists. 2. Propeller type, horizontal axis propeller. 3. Electromagnetic or acoustic meters, modern, no moving parts, more precise. Current meters measure water velocity directly and, combined with cross-sectional area, give accurate discharge estimates. They are considered a standard method in hydrology and are often used to establish rating curves for staff gauge measurements. An acoustic Doppler current profiler, ADCP, is a hydroacoustic instrument that measures water velocity profiles and discharge using the Doppler effect of sound waves. It sends out sound pulses into the water. The pulses bounce off particles, sediment, plankton, bubbles. The frequency shift of the reflected signal is proportional to water velocity. Advantages for this method is: 1. Fast and accurate discharge measurement, much quicker than current meters. 2. Provides full velocity profile across depth and width. 3. Suitable for wide, deep, and fast rivers. 4. Can collect additional data, e.g., depth, sediment transport, backscatter intensity. 5. Non-intrusive right-pointing arrow. No need to place instruments directly in flow. In short, as summary, float gauging right-pointing arrow cheap and simple, low accuracy. Weir's right-pointing arrow good for small flows, structural installation needed. Staff gauge right-pointing arrow long-term monitoring, needs calibration. Dilution gauging right-pointing arrow good for rough, turbulent streams. Current meters right-pointing arrow standard, accurate, but time-consuming. ADCP right-pointing arrow modern, very accurate, but costly.
Test yourself. Let's go. 1. River discharge, also known as streamflow, is defined as a. The velocity of water moving in a river channel. b. The depth of water in a river channel. c. The volume of water flowing through a river channel per unit time. d. The amount of rainfall entering a river system. The answer is C. 2. The standard unit for measuring river discharge is a liters per minute. b. Cubic meters per second. c. Kilograms per second. d. Millimeters per day. The answer is B. 3. Which factor directly influences river discharge? A. Rainfall and snowmelt. B. Groundwater contribution. C. Catchment characteristics. D. All of the above. The answer is D. 4. Which of the following methods requires a rating curve to convert stage, water level, into discharge? A. Staff gauge. B. Float gauging. C. Dilution gauging. D. ADCP. The answer is A. 5. Which method provides both velocity distribution and discharge but is time-consuming in large cross-sections? A. Current meters. B. Weirs. C. Float gauging. D. Staff gauge. The answer is A.